So here we have another trig equation to solve. And in this one, you'll notice I don't have one trig function. I don't even have two trig functions. There's three separate trig functions. There's a cosine, a secant, and a tangent. And we have to sort out what we're going to do to solve this thing. Now, factoring is not going to work because there's no greatest common factors. There's obviously no trinomial terms. I don't have any squareds. So the next idea is to use this trig identity substitution that we've been talking about as an alternative to getting ourselves towards some kind of a factored form equation that we can solve. And the three trig identities that we focus on in this unit are quotient identities, Pythagorean identities, and double angle identities. Well, double angle identities I can probably rule out. I'm not sure, but probably because there's no double angles. It's all omegas. Now, sometimes double angles come up in funny ways, but we'll get into those later. There's no double angle in this one. Pythagorean substitutions. Those don't look promising here because I have no squared exponents. So that means no Pythagorean substitution. There's only one thing left, quotient identities. So what can we do here? I want to pull an old technique from when we were proving trig identities, and I want to rewrite everything in this equation using quotient identities and reciprocal identities. So this becomes, instead of 4 secant, it becomes 4 over cosine. And instead of 5 tangent, we're going to say that's 5 sine over cosine. Okay, look what I did there. That was a quotient identity and reciprocal identities. So after you make those substitutions, and everything is in terms of sines and cosines everywhere, we've got an idea for what we can do here. If only I had common denominators on everything, I could cross out those cosines on the bottom. Or another way you can think about it, if you prefer this way, we're just going to multiply both sides by cosine. Okay? Everything on this side gets multiplied by cosine, and everything on this side gets multiplied by cosine. Now, here's one area you want to be a little careful in with trig equations. When you're multiplying by cosine on both sides, if you make all the cosines disappear, that's potentially a problem. But if you save the cosine information somehow, we've talked about this in class. See, these cosines are just going to cancel out. I'm possibly losing some information there, but these cosines over here are just going to square together. They're not going to, nothing's going to cross out on the left. So because there's a side on the equation where nothing crosses out, I'm probably okay here. So what do we get? We get 2 cosine squared omega equals 4 minus 5 sine omega. And now we're stuck again. We don't know what to do because I can't factor it. There's no GCF. There's trinomial factoring is not going to work too well because there's different functions. Now we use a Pythagorean identity. Okay, so let's change ink here. This is a Pythagorean substitution I need to make. Looks like a Santa Claus substitution because I can just say 2 times 1 minus sine squared omega equals 4 minus 5 sine omega. And look at that. Now everything's in terms of sine. I just need to clean it up a bit, but I think we have made our big breakthrough now. So 2 minus 2 sine squared equals 4 minus 5 sine. And now we get everything over onto one side. I would like 0 on a side and a positive squared term on the other side. So that's how I know which side to work on. I get 2 sine squared on the right minus 5 sine omega. And it looks like after I subtract 2 over, I get plus 2. So this part should be familiar factoring, right? This is going to be 2 sine omega and sine omega. And if we just do a little guesswork, we can come with minus 2 and minus 1. Okay. And if you test this out by foiling, you'll see we get ourselves back to the equation right above. That's always a good thing to double check because if you mess up your factoring, your solutions aren't going to be right. So now I have 2 equations. Sine omega minus 2 equals 0. And that leads me to this. Sine omega equals 2, which is not possible. That's a DNE. Okay, an extraneous solution, it is outside the domain of the sine function, or outside the range of the psi function. You can't get something bigger than 1 when you take the sine of an angle. And my other equation is 2 sine omega minus 1 equals 0. So that's 2 sine omega equals 1. That's sine omega equals 1/2. And if you think about your unit circle, sine is the y values. So that's going to focus on y values that are positive 1/2. Okay, these are shallow angles. That's going to be things like, well, pi over 6 and 5 pi over 6 in quadrant 2. So big breakthroughs here. All this stuff in blue is kind of what we know how to do already, right? That's your introductory trig equation stuff. The red part is where we kind of introduce some new topics at the beginning. The quotient identity, reciprocal identities first, because there didn't seem to be any Pythagorean stuff I could work with here. And then look at that, Pythagorean jumped out as a useful tool halfway through the substitutions. Okay, so just play around with those identities. Remember, we're going to focus on generally these 3. And as you work those together, you may be able to get yourself to this goal, factored form. And then you can solve your equation.